Okay, now we're going to graph logs. So it's funny because a girl last period, she's like, is this the same thing we did before? Like when you looked at the exponentials, it's going to feel the same. It's not the same. It's a different graph. Look at the graph. But it's so similar, it's going to feel like the same. Easy. Okay. All right. Here's the first thing I want you to know. Look right here for 2 seconds. I got a little, just like this much, can barely see, frustrated last period. So I had people like sleeping and not paying attention. That's when you're going to get in trouble with logs. Like if you want to pay attention, you got to focus. Okay. So stay with me. School's going to be out in less than an hour. So push to the last moment. Okay. The word log begins with an L. Okay. The letter L looks like a vertical line. So a log has a vertical asymptote. That's a very easy way to remember. So when you do an exponential, you're going to say, oh, it doesn't have an L, so it's not vertical, it's got to be horizontal. Okay? All right. Off to the side, I want you to write this down. I want you to go 1, 0, and then I want you to go B, 1. B being the base of the log. Okay? To the side of that graph, or above it, whatever, I want you to write y equals log base 2 of x. Okay, so if they were asking me to graph y equals log base 2 of x, I go, okay, that's a parent graph, and it's a log. So I know I'm going to have a vertical asymptote right there. I know that my graph is going to hit the point 1, 0, so I put a dot right there. And my base is a 2. So I put my pencil at the origin, not at the dot, but the origin. And I go right 2, up 1, curve it in, done. That's how easy it is. You've just got to remember those 2 points. And the asymptote looks like an L. Okay? Everybody look at the graph. Look at the red asymptote. Does that cross the x-axis or does it cross the y-axis? Crosses the x-axis. So you're going to go x equals. Where does it cross the x-axis, everybody? 0. Good. Look at the graph. Domain. Here's x. That's okay. That's okay. I didn't turn mine off today either. Here's domain. Find the domain. So start at the left, turn to the right, go to the right. What's this? If I write this in interval form, what's the smallest number I'm going to put?
0.
A 0. Good. And what's my biggest number? Infinity. How am I going to close my 0? With a parenthesis. Why would parenthesis and not a bracket? You're never going to touch it. Good. The range is y. Start low, move up. Everybody in the room, tell me the range. All real numbers. Okay? And then the x-intercept, if it's a parent graph, is always going to be 1, 0. Okay? Everybody look right here for 2 seconds. Let me just give you one little quick conversation here. You guys just sit and relax. This is a parent graph. You have the log, you've got your base, and what you're taking the log up. That's all one thing. It's all stuck together. There's nothing else over there. This guy is not a parent graph because you've got an adjustment and an adjustment and an adjustment. The parent to that is the equation without all that yellow stuff, y equals log base 4, but that is not a parent graph. Who says I understand? Okay, wonderful. Okay, let's come right here. I want you to change this to y equals log base 4 of x. Okay, tell me what page we're on, would you please? 96. Okay, I want to change it on my paper. Okay, sorry, give me 2 seconds. Yeah, I did. Okay. All right, everybody in the room, parent or not a parent?
Parent.
It's a parent. Parent log. So the asymptote is going to look like an L. You guys, these graphs are silly. I did all this work in the summer, and for some reason, I copied and pasted a graph that has an actual graph on it. It's supposed to be an empty XY axis. So all those curves that are there are not supposed to be there, and it makes it confusing, and I'm sorry. Okay? It's a parent log, so you know you're going to hit the point 1, 0. And my base is a 4. So you put your pencil at the origin, and then you go right 4 and up 1, and you curve it in, and there's my graph. That easy, okay? maybe take your pencil and very small scribble through that's there. And I'm very sorry for that. Okay, everybody look at the graph and let's just shout these answers out. Tell me the domain of that graph, everybody. 0 to infinity. Tell me how to close my 0. Guys, more than just one person. How do I close it? With a parenthesis. Talk to me about the range. All real numbers. Good. Asymptote, talk to me. X equals 0, crosses the x-axis. The x-intercept is, tell me, 1, 0. What's the y-intercept? There is none. For which values of x is the function increasing? Everybody look right here. I'm not trying to be negative. I'm just trying to be real. I think if I were to ask you that question right now and put it on a test, I think half of you would miss it. Because I feel like we're starting to get just a little bit confused on increasing, decreasing, constant. Increasing, decreasing, constant are x values. You travel from the left to the right. So if I'm right here and I'm traveling from the left to the right, the first place that I'm even going to hit the graph would be like down here. So you tell me, as I'm traveling from the left to the right and I go along the graph, what's my graph doing right here? Increasing. So where does the increasing begin? Tell me that. 0 is correct. And remember, with increasing, decreasing, constant, I always close with a what? Can you tell me? Always a parenthesis. And how far will for how long will the graph be increasing? Forever. So 0 to infinity, and that's it. Who says, I think I would have gotten that right? Let's see. Yeah, just curious. Okay, now the silly table. Okay, the table's silly because the table is supposed to help you graph, but I just graphed and I didn't even use the table. Okay, so we're just going to jump through hoops. We're going to fill in the table in case you're ever given a table. Okay, everybody write down y equals log base 4 of x. And now to fill in the table, I'm going to convert it because it's awkward to fill in a table if it's in log form. So let's write it in exponential form. So it's 4 to the other side, which is a y, is equal to x. And then if y is a 0, 4 to the 0 is a 1. If y is a 1, 4 to the first is a 4. If y is a 2, 4 to the second is 16. What if y is a negative 1, everybody? 1/4. And you're done. That's it. Okay, let's do this one. Everybody in the room tell me, parent or not a parent? Parent. It's a parent. So dash in that asymptote that looks like an L. It always hits the point 1, 0. Pencil at the origin. How far do I go right before I go up 1? 3. Right 3, up 1, curve it in. There we go. Then I'm going to just take my pencil and very lightly scribble through that thing, and I'm sorry. Everybody in the room, let's just fly through this. Domain, what is it? 0 to infinity, zeros with a parenthesis. Range, talk to me, guys. All real numbers. Asymptote, x equals 0. X-intercept, 1, 0. Y-intercept, none. Increasing, 0 to infinity. It was exactly the same as the other one. It's going to be the same for every parent log. All those answers will be the same. Okay, let's fill in the table. Everybody write down y equals log base 3 of x. Let's convert it. 3 to the y equals x. If y is a 0, 3 to the 0 is a 1. Y is a 1, 3 to the first is a 3. What if y is a negative 1, everybody? 1/3. Yeah, done. Who says this is easy? Told ya. Told you could do logs. Told you logs were easy. Okay. Answer this question in your mind. Nobody shout this out. Is an ln a log? Don't tell me. Is an ln a log? Tell me. Yes. Yes. An ln is a log. It's a log base e. Everybody write down y equals log base e of x. So an ln is a log, right? Is that a parent graph? Yes or no? Yes, it is. So dash it in. It definitely hits 1, 0. Look what people do. Just look forward and watch me do this wrong. My base is an E. Watch what I do. E is how many? 2.7. So 1, 2, and a little bit more. Up like that. There's my graph. It's wrong. Don't do that. What did I do wrong?
You didn't start at the origin.
I have to start at the origin. Where did I start at, bud?
1.
I started at this point right here, right? I can't do that. It's from the origin. Right 2.7, up 1, curve it in. There's my graph. Okay, just do a little scribble, get rid of that guy.
But you still do go over 2.7. Right?
2.7, yep, and up 1. Yes, honey?
Wait, so how do you decide that it's a parent graph? Is it just if it has numbers around it?
Correct. No numbers, no sign. It's just like boring. It's just the log, the base, and it's always going to be an x. Yep, good. Okay, domain is, shout it out, everybody. 0 to infinity. The ranges tell me. All real numbers. Asymptote. X equals 0. X-intercept. 1, 0. Y-intercept. There's none. Increasing. 0 to infinity. Let's do our table. Everybody write down. When you graph, April, why am I saying your name wrong? Not April, A. Tell me. Ashley. I'm so horrible with names, but it's my new, I get through a term and then I'm like, okay, now I'm going to tackle it. I'm sorry, Ashley. So when you graph, I think your exponentials and logs, I think they're always going to be parents. In 1050, we do adjustments, but in this class, I don't think we have any adjustments, okay? Okay, let's convert it. E to the y is equal to x. So if e to the 0, e to the 0 is a 1, e to the first is an e. Someone tell me what e to the negative first is. 1 over e. Yeah, good. Okay. Grab your highlighter for me. Okay. An exponential equation is the inverse of a log. Highlight that. How do you find an inverse? You've done this before. How do you find an inverse? You switch the x's and y's, and then what? Solve for y. Yes. Okay. So this is a log. Let's make the x a y and the y an x. So now we have log base 3 of y is equal to x. Okay, I want you to write the word stuck. And then I want you to draw an arrow and I want you to write the word convert. I'm going to say that every time I see you until we're done with logs. It's going to be just like a common thing. That is stuck. This left side, guys, a way to make the connection, that left side is a parent graph. Okay, if it looked like this, just look right here. You don't have to write anything this down. If it looked like that, I'm not stuck. That -1 is not part of the log. How do I know it's not part of the log? Because I don't have parentheses. So if that were the problem, I would not be stuck. I would add 1 to both sides and then my log would be alone. Who says I understand that? Okay, what if I had a 5 right there? I wouldn't be stuck. I'd move my 1 over, and then I'd divide by 5, and then I'd have my log alone. Who says I understand that? I understand stuck. Okay, you have got to understand stuck. So look at my guy. Stuck or not stuck? Somebody tell me. Stuck. Stuck. Now I want you to freeze right here. If you can understand the next minute and a half of this lesson, it's going to clear up a ton of mistakes that you might make. Everybody look right here. The square root of x plus 1 equals 4. You don't have to write any of this down. I'll tell you when to write. Would it be acceptable to subtract 1 and you get the square root of x equals 3? Yes or no? No. No. Every person in this room knows no way you don't do that, right? The same idea applies over here. Some people will do this. Guys, look. They look right there and they're like, okay. Trying to erase that, highlight it, it won't. They say, okay, well, I don't want the 3, so I'm going to divide by 3. You guys, the 3 is embedded in that log. It's part of the log. Just like the 1 over here is embedded in the square root. It would make sense to divide by 3 if I had a 3 right there. If there's a 3 that's multiplied, then I would divide to get rid of it. Who says I understand that? Okay. Some people will do this. Some people say, okay, I want to solve this, so I'm going to divide by y. That doesn't make sense unless the y is multiplied by the log. Who says I understand? Okay, so we're stuck. There's literally nothing you can do. Everything's done. Everything's stuck together over there. So what do you do when you're stuck? You convert it. So now you go 3 to the other side, which is an x, is equal to y. We're done. Like literally, it's already solved for y. That's your answer. So we started with a log, and our inverse was an exponent. Okay, the symbolism for inverse is f to the negative first of x. So write that down. So the inverse is 3 to the x. Now on this particular problem, it really doesn't make sense to label it like that because the original problem, see that y, it wasn't written as f of x. So if that's written as f of x, then you should write the inverse as f inverse of x. Who says I understand? Okay, great. Let's come right here. Take your highlighter. A log is an inverse of an exponential. So now they've given me an exponential, and I'm going to find the inverse. Everybody go 9 to the y is equal to x. Look right here, big moment. Can I divide by 9 and get y equals x over 9? That would be like this. If you have 2 to the x power is equal to 4, or let's even do it better. Make it more clear to you. Look, 2 to the third equals x. That's like dividing by 2 and saying that 3 is x over 2. You know that can't happen, right? So the same thing can't happen over here. You can't do it. We are what, everybody?
Stuck.
We're stuck. So as soon as you're stuck, you convert. So you write this as log base 9 of the other side, which is an x, is equal to y. Guess what? You're done. All you have to do is just convert it. Switch the x's and y's and convert it. Who says I understand? Okay, good. Okay, here's example 4. It's going to feel like when we did inverses before. It's going to feel a lot like that, okay? I'm going to give you some steps that I think you should follow. You don't have to, but I think you should, okay? The first thing I want you to do is I want you to graph f of x. So everybody write y equals 4 to the x power. Let's see if you know this answer. That's exponential. Is my asymptote horizontal or is it vertical? Everybody tell me.
Horizontal.
Vertical looks like an L, which means log. That guy is not a log, so it's got to be this way. Who says gotcha? Okay, don't ever forget that. So this is right here because it's a parent graph. I know it's going to hit the 0.01. Parent exponentials always do. Then I put my pencil at the origin, and I go right 1, and then I go up, tell me, 4. Goes up 4, curve it in, looks like that. I want you to label it f of x, and then I want you to take your pencil and just teeny tiny scribble out that little piece that's not supposed to be there. Okay? What did I do next on the other inverse lesson when we did that? Do you remember? What did I say was the next logical thing to find? What's something easy you can do right now? You're exactly right. It's a domain and range. So find the domain and the range and the asymptote of f of x. Look at the graph. Everybody in the room, what's the domain? Good. Left to right, it's everything. All real numbers. What's the range? Range is y. Start low. What's the lowest y? 0. Do I close it with a parenthesis or a bracket? Parenthesis. No bracket because it's never going to hit it, right? How high does it go? Infinity. Look at the red asymptote. What's that equation, everybody? Y equals 0. What is something we can find right now that would be super easy? Like 15 seconds. Boop, got it. The y-intercept's not on there though. So what on that paper can I find next that would be like logical?
Table.
Say it again. We could do the table. I'm actually going to do that next after this first thing. As soon as I show you, you're going to remember. We're going to find the domain of the inverse and the range of the inverse. Do you remember that now from the other one, right? How do you find them so like almost instantaneously? You switch them, right? So if this domain is all real numbers, this range is all real numbers, that range is 0 to infinity, this domain is 0 to infinity. Who says, yep, I remember now. Okay, now I'm going to do the table. Okay, so I'm going to stay step number 4. I'm going to fill in the table for f of x and the inverse. It's also quite simple. Look at the green graph. Just list some points that are on that. Well, 0, 1 is one of them. Another one is 1, 4. I could do 2, and then 4 squared is 16. So I could do 2, 16. I'm not going to do that because I can't see it. I'd like to see it. So I'm going to do negative 1. And then what's 4 to the negative first, everybody? 1/4. Somebody tell me how to find the table for my inverse. You just flip them. So easy, right? 1, 0, 4, 1, 1/4, negative 1. Now, what I would do is I'm going to plot my inverse points. You guys, the inverse is supposed to be a what? Somebody tell me that. The original graph, look right here. The original equation is a what? It's an exponential. So the inverse is going to be a log. Let's plot it. 1, 0 is here. 4, 1, right 4 up 1. 1/4, negative 1, right 4 down 1. Okay. Now, then you look at it and you're like, oh, that's a log. I know that. It's going to curve like that. Now that log graph is not complete. What's wrong with my log graph? There's no asymptote. And the asymptote of a log graph looks like an L, right? So it looks like that. Okay? So the 6th thing I did here is I actually went and graphed my inverse. Okay? The 7th thing I'm going to do is I'm going to find the equation for the inverse. And you have to show work for this, just like we did on the other one, on the other inverse problems, right? So switch your x's and y's. So everybody go x equals 4 to the y power. What am I going to ask you? Are we stuck? Are we stuck right there? Yes. And when you're stuck, what do? Convert it. So this is going to be log base 4 of the other side, which is an x, is equal to y. That's my equation for the inverse. So everybody go log base 4 of x. Put f inverse of x equals, not colon. And then only one thing that I haven't found on that whole example, and that's the asymptote for the inverse. What's the asymptote for the inverse? Yep, x equals 0. Done. Okay, who says I totally get that example? Let's see how you're feeling. Okay, good. Let's keep going. Okay. Yes or no? Is a log an inverse? Yes. And then let's say a log is an inverse of finish, an exponential. An exponential is the inverse of a blank, of a log. Good. Okay. The rest of this lesson, I think, is easy. I think you're going to be like, easy for the rest of it. Okay? Finish my sentence. What do I keep saying to you? If a person doesn't understand logs, it's because they weren't paying attention, is exactly right. They were sleeping or doing something bad. But what is the root of their confusion? What is the reason they're confused? They don't know the rules. Thank you. They don't know the rules. That's always it. Always. So you know the rules, home free. Okay? Okay, hook these together and tell yourself I've got to memorize these rules. It's just a bunch of rules, you guys. The left, I want you to write condensed. The right, I want you to put expand. Let's not put past tense. Let's say condense. No, it would be right. Condensed and expanded. It doesn't matter. You get the idea. Okay, if something's condensed, I would write this down. You write the word log one time, just one time. Okay, product property. Product means multiply. Okay, so everybody write down log base A of B times C equals. So the B and the C are multiplied. That's why it's product. Condensed means squished in. Expand means make it big, right? So if they're multiplied, what do I do to those, the B and the C? What do I do when I expand? You write them both with logs, and then what do I do to those two statements? You add them, is exactly right. So it's log base A of B plus log base A of C. When you multiply, you add. The reverse is true. If it's expanded and you're squishing them in, you multiply. Okay? Quotient. What does quotient mean? Divide. So this is log base A of B over C. I only wrote log one time. So if they're squished and they're divided, what do I do when I expand it out? You subtract them. Yep. So it's log base A of B minus log base A of C. The guy that's on the bottom, the C, that's the one with the negative sign. Okay? Power property. This one is nothing new. You already knew this. Look, log base A of B to the C. That's condensed. What do I do to expand this? We did it last time. Bring the C down. That's easy, right? C times log base A of B. Okay, let's do it. Let's use these rules now, okay? Everybody look at example 6. Take your pencil and put parentheses around the 2xy. I like it way better like that. Everybody freeze for 2 seconds. I'm going to write log 3 times right now. One for the 2, one for the x, and one for the y. They are separate things. They each get their own log. Who says gotcha? Let me see that. Okay, great. Okay, and since they're multiplied, when I expand them, they're going to be, tell me, added. Good. So everybody go log base 2 of 2 plus log base 2 of x plus log base 2 of y. If this were a test or a quiz and that was your answer, you would not get full credit. What's wrong? Log base 2 of 2 is a 1. You're exactly right, sweetheart. So this is 1 plus log base 2 of x plus log base 2 of y, and that's your answer. Question B is the most commonly missed question, period. On expansion and condensing, it's always B. I want you to put parentheses around it. You don't have to, but it's way better. Don't do it yet. Let's talk about it for a second. How many times am I going to write the word log right now? How many? 3. 1 for the 4, 1 for the x, and 1 for the z. Who says I understand that? Okay, the guys that are on the bottom are negative. That's all you have to do. It's like so simple. So you just go log base 3 of 4 minus log base 3 of x minus log base 3 of z, and I'm done. You can make it easy or you can make it tough. Let's just make it easy. Top, positive, bottom, negative, done. That easy. Okay? Bless you. Okay, everybody look right here. We're still on B. Listen what people say to me. They're like, well, I don't understand that. Because these are multiplied. And when I multiply, I'm supposed to be adding. So why is that not a positive? Okay? Who said I was just thinking that same thing? Be real. Okay. I'm going to show you, and I'm only going to show you one time. And then I don't want you to think about it like that anymore. I want you to go top, positive, bottom, negative, done. Okay? Okay, everybody write this with me. Underneath this, write log base 3 of 4 minus log base 3, and then in parentheses, x times z. So I kept those together, even though they're separate things. Now I say, okay, that's great, but these have to be expanded further, which means I'm going to add. Okay, so everybody write log base 3 of 4 minus all of it, which is log base 3 of x plus log base 3 of z. What would I then do, everybody? Distribute the negative, which changes both the signs and put us back up to where we were before. Top, positive, bottom, negative, done. You don't have to do all that business. Just remember. Okay? Okay, question C. Question C is a breeze. What do I do to expand it? Bring it down. 3 log base 2 of x, done. It's more expanded. Okay, question D. I feel a little concerned that you're not answering this question correctly. Let's see. Tell me nice and loud so I can see if you understand. How many times will I write the word log right now? 3. I heard lots of 3, so now I'm feeling more confident with you guys. Okay, here we go. So it's going to be log base 3 of x to the third plus log base 3 of y to the second plus log base 3 of z. We are not done. What do I have to do? Pull your exponents down. You guys are so awesome. So this is 3 log base 3 of x plus 2 log base 3 of y plus log base 3 of z, and now I'm done. Who says this expansion stuff is easy? Raise your hand if you feel like that. Yeah, it's easy. You just have to know the rules. That's it. Okay, look at the next one. Everybody in the room. Well, first of all, is an ln a log? Is it going to follow the same rules? Yeah. How many times will I write ln? 3. Of those 3 times, how many will be negative? 1. Which one? The x. Why the x? It's on the bottom. Easy. ln y squared plus ln square root of z minus ln x. Take your eraser. Get rid of the square root of z. Get rid of the square root above the z. And change that to a z to the, tell me, 1/2. Square root of z is z to the 1/2. Are we done?
Nope.
What do I do? Exponents, right? So we have 2 ln 2 plus 1/2 ln z minus ln x. Done. Okay? Now we're going the other way. And it's going to seem exactly the same. It's exactly the same except opposite. Opposite order. The last thing that we just did has to be the first thing that we do here. What do? Pull them up, right? So this is 1/3, and this guy's 5. So now I have the log of, I'm not going to write x to the third. I can't write x to the third. It's not fully condensed. What do I write? Cube root of x plus the log of x minus 3 to the 5th. If I'm condensing, I'm going to write the word log 1 time. So here I go. 1 log. Those are added. So when I squish them, they're multiplied. And it looks like that. You guys, if I leave it like that, that's confusing. Because what I'm taking the log of is like so complicated, right? How do I make it clear? It's easy. How do I make it really clear? Right? You could do parentheses, but then I've got parentheses and parentheses. So the next thing after parentheses is usually brackets. Okay? Okay, question B. Pull my exponents up. So this is a 4. And that's a 2. So now I have the ln of x minus 4 to the 4th minus the ln of x squared. Now I'm ready to squish. Since I have a negative, I know I'm going to have a fraction. Tell me what goes on the bottom. The x squared. Yeah. Why the x squared on the bottom? Negative. Yeah. X minus 4 to the 4th. Positive. Done. Don't change your notes. But what if it looked like this? Does the order matter?
Yes.
It doesn't. It doesn't. The order doesn't matter. You could have the positive first and then the negative. So if it looked like that, how would it change my answer? It'd be upside down in there, right? Since the x minus 4 was the negative, it would be on the bottom. The x is second's a positive, it's on the top. So the order doesn't matter. You just look at the sign, and that's where you put it. Okay? All right. Question C. Pull your exponents up. So this is the log of x to the 1/2. What's x to the 1/2? Square root of x. Plus the log of y to the 4th minus the log of 4 minus the log of p to the 6th. One log, and I know I'm going to have a fraction, and I know it's going to be complicated, so I'm going to do brackets. Anything that's on the negative, anything that is a negative goes on the bottom. So on the bottom goes a 4 and a p to the 6th. Anything that's a positive goes on the top. So that'd be the square root of x and y to the 4th, and I'm done. Who says easy? I get all this stuff. I'm good at it. Let me see. Okay. Yay. Okay. See this log base 2 of 8? Yes.
You can go just a little bit slower on it.
Yes, yes. Thank you for asking me that. No problem at all. Okay. See that log base 2 of 8? They're trying to get you to write it as log base 2 of 2. If that said log base 2 of 7, would it be possible to write it as log base 2 of 2? No. But an 8 totally works, right? So this is going to be log base 2 of x minus 1 squared minus log base 2 of 2 to the, tell me, 3rd. Good. Plus log base 2 of x plus log base 2 of 2 to the 3rd. Negative log base 2 of 2 to the 3rd, positive log base 2 of 2 to the 3rd, those just undo each other. They go away. So now I have log base 2 of x minus 1 squared plus log base 2 of x. Now I squish them together. When I squish them together, they're going to be multiplied. So inside of there, I have an x and an x minus 1 squared. I'm going to clean it up by adding some brackets, and I'm done. Who says I got it? I feel good. Okay, you okay? All right. Yep, you're good. One last thing. The log on your calculator is log base 10, right? So look at part A. How in the world am I going to get a decimal for that if it's not log base 10? Okay, it's easy. Look what you do. You just take the log of the big number, that would be 30, not big in size, not because 30 is a larger number than 4. It's because the size of it is bigger. Hopefully that makes sense, the physical size of it. Okay, so it's the log of 30 divided by the log of 4. That's all you do. So grab your calculator and go log 30, close it off, divided by log 4, close it off, hit enter. Now it's ugly. It doesn't end. It's like keeps going, right? Look at the directions, and let's say that the directions said to round to 4 digits. So it'd be 2.4534. Done. Okay, I want you to cross out B, and I want you to look at C. I'm going to add something else on B. How do I do that? I'm just going to go the log of, everybody tell me what to put. 1 over 64 divided by the log of, tell me what this is. 4. And you have to put parentheses right there. Well, parentheses are going to pop up. Okay, so everybody go log 1 divided by 64, close it off, divided by log 4, close it off, hit enter, and I get -3. That's how to evaluate something that is not log base 10. Who says I understand? Okay, now I had this grand idea to do last period, and it wasn't as grand as I wanted it to be. So let's make this guy grand. I want this to be like a moment where you're like, oh, that makes sense. Okay, I'm gonna override that and change it to something else. Okay, everybody go ln4. If you were evaluating the ln of 4, there's an ln button. So everybody just go ln4, close it off, hit enter, 4 digits, 1.3863. Done. Easy. Draw a line. ln is the same thing as, tell me, log base e. So log base e of 4. Above the line and below the line are the same because ln is log base e. If I wanted to do that on my calculator, I would go log of 4 divided by the log of e. Who says I understand that? Okay, here's the big question I want you to ask. Don't do it yet. When I put that in my calculator, what am I going to get? The same thing that you got up above. Why am I going to get the same thing? Because it's the same thing. ln4 and log base e of 4 are the same. So everybody grab your calculator and go log 4. Close it off. Divided by, now this is tricky in your calculator, so I hope you're doing it with me. Hit log. How do I get that e? What do I push? It's actually second ln. Do you see how it's on the face of the calculator? So yes, hit second ln. And now it looks so weird. They want me to put an exponent on the e. So what's it going to be? It's just going to be a 1. So you're going to hit 1. Close it, enter. You got exactly the same thing. So the ln button is just programmed in a way to do that, but with just one click of the button. Who says I understand? Okay, you guys are so awesome. Okay, that's it. Now, there's a lot of things that we're going to do right now in the next 5 minutes, okay?